Hi, so we're going to take a look at our first section of notes for concept 1. So some of you may have already kind of had the later sections of these in class and are watching them after the fact, and some of you might be starting with this. So wherever you're at, please know you will get a notes packet, and this information will be filled in for you. So if you want it, if it helps you to take notes on a separate sheet of paper, you can, but otherwise you will have access to all these materials if you don't already. Okay, so we're just going to really review some of the types of functions that you've seen in all of your previous courses here. Our first unit is on functions, so we're going to be talking about linear functions, exponential functions, polynomial functions, quadratic functions, all those things that you've maybe seen in your Algebra 1 and Algebra 2 courses. We are going to start with a quick review of what a function is. So the formal definition of a function is a set of ordered pairs for which each independent variable x is paired with exactly one corresponding dependent variable y. So a lot of times we're talking about an infinite collection of points, so like a graph, right? And when we talk about this in Algebra 1, we talk about something that passes the vertical line test, right? For every input, there's exactly one output. So this would be a function, but for example, this would not be a function because when I draw this vertical line, this x value, let's say it's -1, has two y values, maybe one at -1 and one at +2. You will see this in my other video, but the x-intercept is where it crosses the x-axis and the y-intercept is where it crosses the y-axis. So for example, this would be an x-intercept where it crosses the x-axis, and this other point right here would be a y-intercept. Also just remembering here that the x-axis is actually where y equals 0 and the y-axis is actually where x equals 0. So you've seen this before, but a lot of times just using f of x instead of y equals. So for example, 2x minus 3, hopefully you recognize as a linear function that's in y equals mx plus b form, but instead of using y, we're using that function notation. If we were to say f of 1, that just means, well, what's the y value when x is 1? So I could input into the function 1, so I would do 2 times 1 minus 3, and that would be -1. So f of 1 would equal -1, which would refer to the coordinate 1, -1 being on that graph. So the x value is 1 and the y value is -1. In this next section, we're going to go over a bunch of the types of functions. A lot of these you've seen in the past in Algebra 1 and Algebra 2. So if you would like, you could just look to or refer to the textbook in section 1-2. You could take notes from there. I'm going to kind of just quickly pause the video, write the notes in, and then go through each type if you'd like to just stay tuned to the video. So the first type of function we're talking about is a polynomial function. So this could be, a first degree, which would be a linear, a second degree, which would be a quadratic, anything that could be written in the form a number, x to a power, plus a number, x to another power. So this is really a fancy way to write that general equation. A more specific example would be something like 5x to the third plus 2x squared plus, it could have a linear term or not, plus 3x plus 5 or something like that. So it's important to notice that the graph could cross the x-axis up to n times, so n being the highest power, this is third power, we can see it crosses 3 times. This is not necessarily a graph of the function in red, but this graph is third power because it crosses 3 times, and it can have up to 1 less than that direction changes. So you see this has 2 vertexes, meaning that it's at least third power. This next function, we should all be very familiar with the linear function. I've put 3 general forms here, ax plus b, mx plus b, and then that point slope form that you may have seen in Algebra 1. A linear function is obviously a straight line. It's got a constant rate of change. So for example, if we were to look at this, assuming that each box is 1, if this is a 1 scale, 1, 2, 3, 4, 5, 6. It looks like this is the graph f of x equals 2x plus 6, where 2 is your slope and 6 would be your y-intercept. Next type of function that you really looked in depth at in Algebra 2 is a quadratic function. So that's really a specific type of polynomial that's second power. Here we have two forms. This is the standard form and this is the vertex form. You may have also seen the factored form in Algebra 2. Important features of a quadratic is that it has one direction change. We call that the vertex. And of course, its domain, just like the linear, is all real numbers. A direct variation function is really just the kind of linear function you may have learned about when you were young. So this is something that doesn't have negative values generally. We use it for real world applications starting at 0 and just going up at a constant rate. So for example, if you were counting something, by fives, let's say it was $5, then $10, then $15, then $20, that would be a direct variation. Generally, the domain is going to start at 0 because we're going to use it for real world applications, and it's a specific type of linear function. You'll notice AX, technically there's a plus 0 here because the y-intercept is going to be 0. A power equation is in a function that just has a number and then x to a power. So for example, 5x squared could be a power function. So notice there's no other terms here. This isn't a polynomial, it's just a simple number, x to a power. So if the exponent is positive, like squared or cubed or to the 4th power, then it's going to contain the origin. Generally for power functions, we're using real world applications, so we're only generally using the domain 0 to infinity. If the power is negative, then we're going to get this kind of asymptote behavior on both the x-axis and the y-axis, where you'll kind of see that have that asymptote, and it could have this other negative side if you weren't looking at a domain of 0 to infinity. Don't expect you to know that right now, but it might come up in the future. Similar to that power function, you might, with a negative exponent, you might come across an exponential function, which you've seen in Algebra 1 and Algebra 2. This does have an asymptote, but not on both axes, usually just along the x-axis, unless there's a vertical shift. So for example, this is the graph of f of x equals 3 times 2 to the x. So you can see it crosses that axis at 3, and then it's kind of doubling as it goes up. So it grows very quickly and then approaches the asymptote on the other side. So an inverse variation function is that special type of power function where you have a negative exponent. We're going to be looking at these a lot more this year. So in this type of relationship, you would have two asymptotes, both a vertical one and a horizontal one. And those are your asymptotes. So you can see kind of a picture here of what that would look like. And it could be written as, a number over x. The x is always in the denominator. Or if you remember, negative exponent really could mean that there's an x in the denominator. So for example, 5 over x or 3 over x squared could be inverse variation functions, specific examples of one. The last type of function that we're going to have a whole unit on this year are what's called rational functions, or a rational algebraic function. And so that's when we take two polynomials and divide them by each other. So f of x is a polynomial over a different polynomial. So I'll just give you an example. You could have something like x squared plus 2x plus 3 over x plus 1. These functions are going to have potentially multiple asymptotes. So you can see I've depicted or tried to depict in all these dashed lines. These are the asymptotes, not actual parts of the function. They could have holes or just like points where the graph drops out. And we're going to explore all those features as we get further into the year. So again, I don't expect you to know or memorize all these functions at this point, but just familiarize yourself with the function types. You should have seen a lot of them before, kind of what their general equations look like, and some of the features of those graphs.